Great. Hello, everyone. It's great to be here at the Crick Institute today. Thank you so much for the organizers for making this happen. So today I'm going to talk about infrastructure for verifiable and composable research. The scientific record is the engine of progress of our species. Today, it lives in the crowd. It suffers from loss of artifacts. Data, code, other incredibly valuable scientific outputs end up in hard drives in universities somewhere. We lose these invaluable artifacts. It suffers from content drift and link rot. The internet, since its inception, was not designed as a substrate for the scientific record. It suffers from brittle PIDs, who were state-of-the-art in 1996. That's how old they are. They're essentially lookup tables, and they break, and they require constant and expensive maintenance. As a result of that, the scientific record is not verifiable. We mentioned the replication crisis and the incentives that surround it. When you read a research paper and you understand that it's a coin flip to know whether you can trust, whether you can believe what you read, this is one of the most pressing problems that we all face. Scientific record is not machine readable. It's expensive to maintain, and it creates bad incentives for researchers. It's a complex, multi-agent system that produces the scientific record. We have scientists who are knowledge creators. We have publishers who are knowledge curators. You have analytics providers and indexers who are there to curate the publishers. And at the end of that, you have CRIS and RIMS, current research information systems. This is how the work of scientists become points and metrics on dashboards of funders and institutions. Now, if we pull the logs from this machine, we all agree that something is deeply broken. Research productivity has gone down. Grant funding occurs to older and older and older people. We have a drop in disruptive science. Something doesn't work. At the same time, I'm incredibly optimistic about what we can do for our scientific record. We live in a rare moment, a conjunction of policy and technology. The OSTP memo in August 2022 changed everything. It mandates open access to peer-reviewed manuscripts, to data that's been publicly funded, without any embargoes possible on these research outputs. And it needs to be machine readable and fair enabling. The FAIR principles stands for findable, accessible, interoperable, reusable. These are the properties that our scientific outputs should have. But today, we're not close. And so it's a momentous time, and that's why I come here with a message of deep optimism. Because there's goodwill at every layers of this incredibly complex system. Everyone is facing a common challenge. We need fair enabling infrastructure. And we need to upgrade our unit of knowledge. The Center for Open Science has a theory of change. We have to build infrastructure to make the impossible possible. We have to create good user experience to make it easy for scientists to share their work. We have to provide values to scientific communities so that we can then make it socially normative to do these right things. And we have to make it rewarding. And this will come naturally if we can satisfy all of these levels. So what should our unit of knowledge be? There's this concept, this idea of research object. Today we've been over-indexing on research papers and under-indexing on all of the other fruits of the scientific pursuit. When we publish a paper, there's so much behind it. There's computational pipelines. There might be regions, research data, video of our procedures, peer review exchange, pre-registered analysis plan, contributor maps, grants. All of this form what's called a PID graph, a PID graph. And it's incredibly precious. And today, we're not nearly there at this ideal. This is very important. Fair enabling means PIDs plus data, plus metadata, plus methods. That's what it takes to make our work optimally reusable so that we can accelerate progress. And where should we store these research objects? Should we put them on a silo in AWS? No. nobody wants that. They should live in an open state repository, a common repository that is accessible to all. And this is one of the most powerful promises of the decentralized web. The idea that we can break the data layer from the application layer to create a common data pool that is open read and open write. And we can take these research objects and store them in incredibly secure and efficient data structures called Merkle DAGs. And we can index these DAGs on a blockchain, on a ledger, to create PIDs, persistent identifiers. This is the master key of the scientific record. And then we can create granular PIDs that allows us to address any linked data object in that entire research object. Today, a DOI costs $1 and is a link between a publisher's website and a string that follows the DOI schema. We can do better than this. And these research objects stored open state need to be composable. So what does that mean? Imagine an infrastructure that is fair enabling, where every type of services can operate on that tree of knowledge to curate it. eLife has long talked about being an overlay platform on a preprint. But who wants to be an overlay journal on top of a PDF with a DOI? No. The overlay systems of tomorrow operate on an open state repository with the code, with the data, with all of these artifacts, so that we can have more than simply peer review. Today we need data curation, data stewarding, we need image certification. We can have all of these services operate on a composable system using the primitives that have been so successful in the software development world, which is Git. But none of this will work if we don't make it powerful. We need to deliver value to scientific communities now, not tomorrow, today. So what does that mean? We can make it so that these PIDs preserve data in a way that protects against content drift, link rot across 3 continents, 5 countries with a hot copy. To store 1 petabyte of data on AWS will cost me $500,000 a year to make it available to my scientific community. It shouldn't be the case. With this system, we can have sponsored storage for 18 months and then a competitive marketplace in which service providers compete for the best prices so that we can essentially accelerate the pace of sharing and reduce the financial barriers across sharing incredibly large data sets. And we need to make it powerful by defining methods to interact and operate on that data. Methods for fair digital object reuse. Data has gravity, so if you have a petabyte of data, it's much more efficient to send the program over to where the data lives than to download the data locally. It's what some of the amazing folks at Protocol Labs have been building with Bacalhau. So in this case, you can take a PID from a research object on DeSci and immediately send a program over to it to run your calculations. But you can also think as PIDs as importable objects. So you can directly, imagine if you could type import DOI fetch DOI/data/measurement.csv, and you'd run that command in Python, and you'd have that data set directly into your IDE so that you could produce new knowledge and discover tremendous things. This is this idea of citations as function call from Balaji Srivanasan. We can do this. We now have the technology to make it possible. But beyond being powerful, none of this has any chance of succeeding unless we nail the user experience. This is fundamental. We have to make it easy for scientists to use. Today, we're familiar with manuscript submission systems. This flowchart up here is what you have to follow in order to make your data available. It shouldn't be this way. It should be easy. Creators of all forms have fantastic tools. Scientists have manuscript submission systems. Developers have GitHub, designers have Figma. We need to find scientists where they are today with the tools that they use and that they love. We were talking to editors of scientific journals. The number one request when a scientist says, I would like to share my data, it's like, can I send you a Dropbox link? It's like, no, we're not equipped for that. Please follow the flowchart. It shouldn't be this way. It should be easy. We should create tools that integrate everything that scientists love and know in order to create composable research objects that are stored open state. So I'll give you a little demo of what we've been building. Just a second. Okay, so you're on a website like this, NIH Library of Medicine. Where do you want to go as a scientist? Well, you want to run away. You want to go to this button, right? You want to go to the PDF. That's where it's like, oh, finally, I got my content. I can read it. That's where I feel good. I'm in the right place. So what do we have here? We have an embedding with a PID, this persistent identifier. We can click on this embedding. We have a decentralized registry. We have here in this case a cover art generated by AI on this paper. And you're back into that comfortable area. Now, the difference is you have a mysterious icon, which actually has all the richness tied to this research object that you've created. You can have code, you can have reproducible notebooks, you can have data, you can have videos. You have this ability to create these research objects. We also have attestation and verifiable attributes. Imagine if you had institutions and service providers that could certify that your data is fair with verifiable attestations. This is possible. Imagine the richness of having an entire economy of systems operating on top of an open state repository, that you could incentivize them openly to perform this verification. You could also create verifiable research easily. You can add annotations, give context to your readers. You can embed provenance to your figures and your result in a really simple way that allows you to reproduce these results, all in the comfort of a PDF viewer. So here, as we can see, we're running an embedded notebook into this research object viewer. You can reproduce these results. You can interact with the code. We also have version histories, perfect version history. It's all based on CIDs, content identifiers. You have provenance, who, what, and when altered and proposed a new version. You have source with all of the contributors. And now, let me show you some new features. We're close to releasing our beta. At the root of every research object, there's this graph of knowledge, where you have all of these artifacts. You could think of that as a file structure, as a folder. We all have research objects as scientists, except they're living on our desktop. So now you have a node drive, a fully fledged IPFS drive with the ease of use of Dropbox, where you can simply post your data, where you can simply post your code. You can have all of the components that live in the back end of your paper. And it's that easy to do. You can create metadata. You can essentially have fair data in an easable way with schemas that can be community defined. And you can reuse them. So here you have the CID of that particular data set. This is the address where this data lives. You can send a program with Bacalhau today on this to run new computation. And that file could be a petabyte or more. It would work. And you can import them. You can import these data sets, this code, using dpid fetch. In a way as simple that it is to import a library in Python. Imagine if this is how we could interact with the scientific record of tomorrow. So DeSci Nodes is an experimental platform that is being built in conjunction with an open protocol, with the open state repository. It's there as a proof of concept, an experimental proof of concept of how we could build research objects and how we could deliver value to scientific communities. It's built like many things on the shoulders of giants. This is a very famous trilemma in computer science called Zuko's triangle. Zuko proposed that there's 3 desirable properties in any naming system. It's human, meaningful, security, and decentralization. And he said, but you can't have all 3. Pick 2. So for example, DOIs are only human meaningful, but they're not even human meaningful because they follow a specific schema. They're not secure, they're not decentralized. They require constant maintenance. CIDs are secure and decentralized. They're not human meaningful. With DPIDs, we can have the 3 properties. And this was an observation that was published in a famous blog post by Schwartz. Aaron Schwartz, the open internet activist who solved Zuko's triangle. And now if you combine Zuko's triangle, the solution to Zuko's triangle, with the invention of Juan Benet, IPFS, content address storage, you now have a system that is extremely powerful because it combines all of these properties and allows us to store data securely in a way that is accessible to all. And this is the ideal substrate for the FAIR principles of Wilkinson: findable, accessible, interoperable, reusable. So remember this. One DPID, decentralized persistent identifier, gives you a PID, data, metadata, methods for every artifact stored in a research object. And it comes with the properties of preservations. Multiple copies keep things safe. 3 continents, 5 countries. It has provenance. Every new version that is posted on this system gives us a trace of who, when, and what. It's interoperable. We have methods. We can send programs over to where the data lives. We can import the code and its functions directly into our IDEs to make our lives better. It's composable with verifiable attestations and Git primitives. And it's accessible. This repository is open state. It does not depend on the willingness of a silo in a platform. Anyone can access this repository and build a new generation of platforms to serve scientists that will today compete on user experience and features, not on the moats created by data. So what could the future look like? Well, imagine if the scientific record was composed of constellations of composable nodes that build off each other, that compute off each other to produce new, verifiable, reproducible knowledge that is accessible to all. We live in a momentous time. It is a conjunction of technology and policy. It is a rare window. The scientific record is our greatest achievement, and we are here to find new ways to preserve it, to secure it, to make it more reproducible, to curate it pluralistically, and create incentives that reward the quest for truth. So thank you. Thank you for the incredible DeSci Labs team. Thank you to Sina, Philip, Adam, Carla, Eric, Remo, John, Shadrach, Richard, Andrew, and Mike, who have made all of this possible. And also to our amazing partners at the DeSci Foundation, a group of amazing meta-scientists. Protocol Lab for being such a enduring and wonderful partner for us, and the Center for Open Science for being such a great source of inspiration to everything we're building. Thank you very much.
Amazing, thank you very much. It's a very long and wordy round of applause as well. So we've just got maybe a couple of minutes for questions, if anybody has any. Yes, we have 2 down here. First drop. That was my fault, actually.
That's all right.
That's all right.
All right, you can hear me. Yeah, thanks for the awesome talk. And thanks for mentioning Aaron Schwartz as well. There's a whole story there. But yeah, thanks for that. Yeah, my question is, why isn't this done in IPLD?
It is IPLD.
Boom. Okay. Cool. Who's next?
Yeah, just seeing the whole graph of everything made me think, are you excited of doing meta studies and meta-analysis on once there's, millions of these nodes all open? Yeah.
Yeah, of course. I think perhaps more important than doing meta studies right now, more important is to create a group of stakeholders that includes meta scientists this time. Because the governance of such a protocol in an open state repository is going to require credible neutrality. And the people that should be sitting at the table are, well, the stakeholders, right? And meta scientists are core stakeholders, right? The people that have blew the whistle on the replication crisis, the people that have been doing amazing work on studying the incentives of the scientific record, those people need a voice. And yeah, I'm very excited about giving them a voice.
Awesome. Thank you.
Are there any more questions at all? We have one down here from Isabel, if you want to throw them.
Yeah, all right.
It looks great, and so you said you're launching the beta. How, if anyone here has looked at it and be like, I want to try this, what's their path to giving it a go?
Yeah, join our Discord channel and get in touch with the people at DeSci Labs. That's one way. You can also email us. You can get in touch with me at the end of the conference. I'm happy to talk to you, and because this is the most important. The lifeblood of these systems are communities, right? But in order to form communities, you need to form infrastructure. So it's really this combination of both forces that is so necessary. So if you're a scientist, you want to try things out, you want to help us build it. We'll take your feedback. We'll make it better. And I think we have a chance to really change things.
We've got one more behind. Very quick though.
Just
so we've got-
logistically, Mike, just keep your eyes out for DeSci.com. So this is where we're going to have the link to the beta. So we're planning to release it at the end of January, maybe a few days more or less. But this is where you will have access to the nodes, and then you can just start using them.
Thank you. Thank you so much, DeSci Labs. Thank you.